physics assignment, ray diagrams. And I want you to do these with a ruler. So you should have a hard copy of this on your tabletop with a straight edge. It doesn't have to be a ruler, something straight. And make a nice diagram. My excuse right now is that I'm on a computer screen that's angled and I can't put a ruler on the screen, so I'm going to have to freehand these. So you'll have to do a better job than I am doing. That's my excuse here. But bottom line is the basic technique is I start with a spot at the top of my object. So this arrow on the left here is my object. I put a little red dot there right now. And there's all kinds of light that hits that. This is a diverging mirror in this case, number one. It's like the back side of a spoon or like the security camera in a store. These little hash marks over here behind the mirror, this is behind the mirror. That means behind the mirror. It's not hair. So the front of the mirror is over here. It's reflective. So if you were standing there looking in the mirror, you would see yourself in that mirror. But we're going to investigate that more fully here, what that means as far as is it a real image or a virtual image, inverted, or upright, which you don't need to answer, but I will expand upon that as I go through here. But this represents light. And you use a ruler to draw that parallel ray of light going in towards the mirror, parallel to the principal axis, which is that black line through F and C. F is the focal length, and once again, the focal length for a diverging mirror is negative 5 centimeters, negative 10 centimeters. You can do these in centimeters, or you can do them in standard units, meters. But if you're consistent with one unit or the other, everything comes out in that unit. If you stay in centimeters, it comes out in centimeters. Here, we're not calculating, we're just drawing a diagram. But bottom line is that particular ray of light does not go through the mirror, but it would be such that if you put your ruler on here such that it lines up like that, this reflection has to be an extension of that dashed line that I drew. The dashed line represents behind the mirror where no light goes, but it's an extension of the reflected ray. I'm going to call that ray number 1. Okay. In the notes, and this is the one we usually stay away from here, but you could draw this one, is a ray of light that goes towards the center of curvature. So if I draw a ray of light that's going towards C, right? That ray of light hits the mirror and it bounces straight back, right on top of itself. So all of that is lined up that I just drew there. So that's all one long line. This long line here is all one extension. Once again, with a ruler, it looks much better. And then step 3. Okay, so you could be done right now. The actual intersection of those two right here, right where they intersect right there, is where the tip of the image will be in that spot. So you could be done now. You don't need to do step 3. But step 3 here is a ray of light that goes towards F. I'll do a little bit better job there. So I'm going to go towards F. Okay, it has to hit F. And then it reflects back on itself. I'm going to do it one more time. Do a little bit better. Okay, hang on. Sorry. Okay. Start a little higher. Okay, so that's going towards F. And it reflects back this way, parallel. All right. So bottom line is now that particular ray, if you go back, it should intersect here as well, but it's not going to intersect there too well. All right. So I'm not going to draw the backwards projection. I could draw the backwards projection there, but that dot represents the top of your image. My image is going to look like this. Let me draw it in blue. So my image there is like this. And that last ray of light, that last ray, this blue one here, should have intersected there as well. Now, I had to kind of fudge it a little bit to get that to work, but I would not draw all 3 of those. I would just draw 2 of that. So all you have to do on a test is draw 2 of the 3, or envision 2 of the 3 to get the image. This is going to be, well, I'll let you tell me what that image is. Is it real or virtual? All right, so basically you need that diagram, at least 2 of those 3. You don't need to draw all 3 of those. Number two. The object starts upside down, so we'll see what happens to the image. But once again, if you start by drawing a ray of light that comes in parallel to the principal axis. Now this is a concave mirror. It's like the business side of a spoon. It's caved in. Once again, the hairs represent the back. So this is the back side. Over here too, that was the back side. But the idea here in a converging mirror is that ray of light reflects through F. Okay, it has to go through F. That's number 1. So in the first case, it never got to go through F because of the fact that F is behind the mirror. It's in the virtual territory. That's number one. Skip step 2. Skip step number 2. Doesn't work too well here. But step number 3 is a ray of light that goes through F, hits the mirror, and it bounces out parallel. Let me do a little better. All right, that's pretty good. That's number 3. It's kind of the opposite of number 1. Number 1 comes in parallel, goes through F. Number 3 goes in through F and comes out parallel. But where they intersect is where the image. So you have to draw the image. I'm not going to do that for you. So that's going to be the top of your image. I'm going to let you finish that. Draw the image and tell me whether it's real or virtual. All right. Lenses. Here we go. Now, F is focal length, and there's a focal length on both sides. It's the same distance. Everything's measured from the center of the lens, this red spot right there. And another thing that's convenient on lenses is to have what's called 2F, twice the focal length. So if the focal length here is 10 centimeters from this red dot to where F is, 10 centimeters, then it's another 10 centimeters to 2F. That'd be like 20 centimeters total. Or if the focal length was 15, then 2F would be 30. Same thing on the other side. Okay, but a ray of light that comes in parallel, okay, it actually bends twice, but you don't need to show a double bend. But the net result is, okay, that's number 1. It goes through F. For lenses, the light refracts. It goes through the lens. For mirrors, like I just did in number 1 and 2, it reflects off the mirror. So that's step number 1. All right, step number 2 is a ray that goes through the spot. Once again, with a ruler, you should be able to do a nice job of this. Okay, so that's step number 2. It had to go through what's one long ray of light that goes through the center without ever bending. There should be no bending there. Step number 3 is a ray of light that goes through F. Okay, so this shows you the progression here. It bends a couple times. Okay, that's number 3. That should be parallel to the principal axis. If everything's perfect, which is not here, but it's in perfect world, where they intersect represents the tip of my image. Once again, I'm going to let you draw the image. I'm kind of doing the problem for you in a sense. What it's supposed to look like. You only need to draw 2 of the 3 of those. You don't need to draw all 3 of those rays. They all should come together in one spot. And if they don't come together in one spot, you kind of average out where they're coming together. Mine weren't perfect, but it was close. Number 4. Okay, and then you can also tell whether it's real or virtual. Circle one of those 2. Now, this was the one that's most often messed up. This is a diverging lens. Okay, diverging lens. So the light comes in, bends a couple times, okay, but what happens here is it bends. Whoops, let me do better. It bends such that, okay, it lines up with this F right here. There's F right there in that spot. Okay, so that number 1 there has to line up with the focal point that this case, the object is on the focal point. So it has to line up with the focal point that's on the same side of the lens as the object. Okay, and step 2 is pretty easy here. It's pretty consistent between all lenses and mirrors to a degree. It's just going to be a ray of light. I'm going to skip step 2. Skip step number 2. Okay, because it's not necessary and it's semi-complicated. It can throw you off. But bottom line, whereas numbers 1 and 3 intersect, or 1 and 3, whenever these lines, the refracted rays or reflected rays intersect, these are refracted mirrors, it's reflected, that's where the tip of your image is. So then draw the image. I want you to draw the image. Okay, and then tell me whether it's real or virtual. So draw the image. Draw the image. Okay, in both cases, in all cases. All right, number 5. Here we have the image, and it's virtual. Okay, so this one is tricky. We have to find where the object is. We have to find out where the object is. So, in general, the easiest one to line up is the one that's with C. Now, the other thing is, I want to think about is that, and you can use your ruler to get a little better, whoopsie, to get a little better idea here, is that there's a spot here that's halfway, okay, I'm approximating it, halfway between C and the mirror, because the focal length is half the center of the radius, because the radius goes to the center of curvature. So you have to figure out where F is. But I'm going to kind of just backwards. I'm going to do number 2 first. In other words, I'm going to take the top of the image, and line it up with C. All right. So I'm going to try to approximate that. Not too bad. All right. So and then there would be a ray of light that would reflect back like this. All right. Once again, I make all my lines dash behind the mirror. All right. Then, okay, the other thing is there has to be a ray of light. Okay, if I take and line up with F now, and this is step number 1. So that's really step number 2. That'd be ray number 2. Doing it backwards, I'm going to go to ray number 1. Now, numbers 1 and 2 tend to be the easier one, but sometimes number 1 is almost always the most convenient. Sometimes we switch between the steps numbers 2 and 3. But if I line up with F, okay, if I line up with F, all right, that means there must have been a ray of light coming in parallel. Okay, so I'm aiming for that spot right there that reflected off the mirror and went like this. That's step number 1. All right, so that's enough to figure out where the object is. So this is a little bit difficult. So that was number 1. A ray coming in parallel, reflecting off the mirror, goes through focal point. That's number 1. A ray of light coming in through the center of curvature. But they both have to come together from the top part of our object. The top part of our object here would be right there. That's our object. All right. So draw the object. Draw the object. Okay, based on that blue spot is the object's tip. Okay, and lastly over here, number 6, once again, we have the image here. So we're doing this problem backwards, so that's why it's a critical thinking problem. So in this case, once again, all right, well, you have 2F and F, but bottom line is, if we do this backwards, if I take the center of the lens, okay, and there was a ray of light that had to come from my object, a ray of light that comes from my object that goes through the center of the lens, all right, so I'm going to draw a line that lines up with those 2 rays of light, or those 2 spots. Okay, so my object has to lie along that line somewhere. Okay, now, once again, I'm going to line up, and you can do step 1 or step 3. I'm going to do step 1. If I line up with F, okay, that would be a ray of light that bent outward from the original. So if I take this spot right here, and draw a parallel line coming in, okay, there's a parallel line coming in, my object's top has to line up with that line somewhere. Well, that's number, actually this should have been number 2 here. Should have put that as number 2. So strike that down here at the bottom. It's a number 2. This is number 1. Step number 1. And where they intersect would be the top of my object. Okay? That's the top of my object. So draw the object. So I've pretty much done all the diagrams except for drawing the objects. You have to draw the objects in there. You have to draw the diagrams with the straight edge, right? And things to keep in mind are that when you're behind a mirror, always draw the lines dashed, because that represents that there's not actual light that goes back there. That's just a extension of the actual light. Same thing with this diverging lens that I just drew here. That dashed line from F to the lens is not actual light. The actual light goes through the lens. So you have a parallel ray of light that comes in, bends away such that it looks like it originates from the focal point, which it doesn't. It's the virtual focal point. These have negative focal lengths. These lenses have negative focal lengths. So when you plug into the equation 1 over F equals 1 over D sub O plus 1 over D sub I, the F has to be a negative number when you plug in there. And then here's your ray of light that comes through the original object, blue dot, and then goes straight without bending significantly. And where those two intersect is where the image is, which is already drawn.